right, so this is graphing exponential functions. This one is going on page 66. So everybody write 66 in the blank because it drives me crazy. You're like, I don't know what page it goes on. I write it in that blank every day, plus it's on your calendar. Right, so it goes on page 66. And we are going to look at what exponential functions are and how we're going to graph them. So an exponential function, where b is the base of the function, looks like this. F of x is equal to b to the x power, b being the base. You can have the base that is greater than 1, and you can have a base that is less than 1, but greater than 0. Okay? And so we are, this right here, it says when a is greater than 1. This really should be when a is greater than 0. Change that to a 0, otherwise it doesn't make any sense. And b is greater than 1. So basically, when b is greater than 1, this is going to be your exponential growth. Okay? Then we're going to mark this out over here. It's not when a is less than 1. We can mark that out. But it's when b is less than 1 but greater than 0. Somewhere between 0 and 1. The function is decreasing and called exponential decay. Okay? So we got exponential growth and exponential decay as our parent functions as far as they are concerned. With these parent functions, that 2 could be a 5. 5 to the x would be that parent function. Like this one, there's a little ambiguous just because we have to have something there as the base. So exponential functions, these are not new to you. Do they have asymptotes? Think about what an exponential function looks like. Yes. So for a parent function, where would that asymptote be? Y equals 0, right? Because there's no exponent that I can use that would give me a negative number there, right? So looks like that, right? So that's true for both of them. They're both the same. For both of these, if x is 0, what is the y value? If I said, what's 2 to the 0 power? No. 1. So when x is 0, y is 1. Even when I have 1/2 to the x, when x is 0, y is 1. Do you see how that is exactly the same for both of them? So for both of them and their parent functions, that's where their horizontal asymptote is. And then that 0, 1 is your y-intercept. Okay, so then let's look at our other points. So when we were doing parent functions, we put little x's or stars or whatever at our anchor points. I'm not going to do that this time. We're just going to put our pencil there and think about what it is without actually making extra points on there. So this is one of our anchor points. You're going to have 3 on all of these. So that's one of them. Then when x is 1, what would y be? When I substitute 1 in here, what do I get? 2, right? So when x is 1, y is 2. I'm going to put a point there. Okay? When we're actually doing transformations, we're not going to, put our anchor points there, but these are our anchor points from our parent functions. When x is negative 1, what would y be? Well, it's still a positive number, yes, because we have that asymptote there, but it's not positive 2, because it's not the same thing. 2 to the negative 1 power, what does that negative do? We have to know our exponential and our exponent rules. Nobody knows? So let's think about what an exponential function looks like, right? So this is going to keep going up this way, right? So isn't it going to have to be down here? Is it going to have to be less than 1? So what do you think it might be? 1/2. The negative 1 gives it the reciprocal, right? Remember when you're doing exponential rules, if you had like x to the negative 1 power, then it would go down to the denominator and become x, right? Changes its place. So 2 to the negative 1 power is 1/2. That's very important that we understand that. So this, when I'm at negative 1, I'm at 1/2. So for your parent function, f of x is 2 to the x power. It's going to look like this. Okay. Now, f of x equals 1/2 to the x power. Well, when x is 1, what is y going to be? When I substitute in a 1 here, what am I going to get? 1/2, because anything to the first power is itself. So I get 1, I'm at 1/2. What about 1/2 to the negative 1 power? What's that going to be? 2, because it's the reciprocal, right? So when I'm at negative 1, my y value is 2. So this decay formula, or this decay graph looks something like this. And although we were able to cross asymptotes when we did rationals, do you think I'm ever going to be able to cross that asymptote? No, it does not make any sense at all here, so crossing this asymptote is not even an option. Okay, everybody okay with all that? Yes? Okay. So now, let's look at these down here. Is this first one here, is this exponential growth or decay? Growth. Okay, so this is going to be growth. And either way, since this is the parent function, there's no transformations happening yet. These are just some number to the x power. My asymptote, horizontal asymptote, would be here. And I would have 0, 1 as a number, or as my y-intercept. Okay. What changes is the other 2 points depending on whatever the base is. So now when x is 1, what is my y value going to be? What's 3 to the first power? 3. So when x is 1, y is 3. So I go to 1, 1, 2, 3. Looks like that. When x is negative 1, what is y? 1/3. Okay, so I go to negative 1 and then 1/3. It's right about there. And I draw in my function that looks something like this. Okay, everybody good with that? Now let's look at the rest of these. What's the domain, or the rest of the parts? What's the domain here? Good. Negative infinity to infinity, which is also all real numbers, but this is how we were writing them for the graphs, so we'll do it this way, but yes, it's the same thing. What's my range? 0 to infinity. Then my y-intercept, 0, 1. Right? Without any transformations, that's what it's always going to be. My asymptote is y = 0. Yeah, be careful with those. Don't get those mixed up. Is it increasing anywhere? Yes, everywhere, right? So negative infinity to infinity. And then that means it's not decreasing at all. Yes. Then my end behavior. As x approaches infinity, what does f of x approach? Infinity. Good. And then as x approaches negative infinity, what does f of x approach? 0. So our end behavior with rationals we looked at as our horizontal and our slant asymptotes, but that doesn't work here because not both ends aren't going to the same thing. They're going to different things, so I have to write it out separately. Okay, everybody good with that? Any questions? All right, so we're going to skip number 2. Let's go to number 3. All right, so this has no transformations, right? No transformations. That tells me my asymptote is still here at y = 0. And I can go ahead and put in there y = 0 over here. Is this going to be exponential growth or decay? Decay, because this is between 0 and 1, right? So this is decay. Then I know that my y-intercept is at 0, 1. Then I have to figure out my other 2 anchor points here. So when x is 1, what is y going to be? 2/5, right? So I go to 1, and then 2/5, which is a little bit less than a half. It's about right there. Then I need negative 1. When x is negative 1, what is y? 5/2, right? 5/2. So I go to negative 1, and then 5/2 is 2.5. So I go to 1, 2.5, right there. And then I've got my 3 anchor points, and I can sketch my graph in. So that it looks like this. So what's my domain here? Negative infinity to infinity. It's exactly the same, right? Now let's think about this as far as transformations go. My transformations are going to move it up, down, left, right, stretch it, and compress it. Is it going to change the domain at all? Nope, that's going to be your domain every single time. My range goes from 0 to infinity. Do I include 0? No, because there's an asymptote there. Now, can my transformations affect my range? Yes. Okay, it can affect my range. Domain it's not going to affect, but it will affect my range. My y-intercept is 0, 1. That can also be changed by your transformations. Then, are we increasing anywhere? No, we're decreasing on the whole thing. So this is none, and then we're decreasing from negative infinity to infinity. And then our end behavior, as x approaches infinity, f of x approaches what? 0. Good. And then as x approaches negative infinity, f of x approaches infinity. Okay. Everybody good with all that? Any questions? All right, so I don't think we need to do the other two that are just like this with the parent functions. I think hopefully we've got that. But we are going to talk about e. Now, e is something that some of y'all are not very comfortable with, and that's okay. But I will tell you, we stay in constant contact with Mr. Ackerman, and I realize not all of you are necessarily going to calculus next year, but at some point, E is going to come up again. So I know we talk about a lot about when you go to calculus. May or may not be what you're doing next year, but eventually you may need to do that when, in college or whatever. But so you still need to have a good concept of what E is. E is just a number. We get that, right? You at least learned that much. I think it was new to you in Algebra 2. It's what we call a natural base exponential function. So this is where f of x is equal to e to the x power. Right? And it's a number, but so e is a blank number. It falls into the same category as pi and as square roots, like the square root of 3. What do we call those kind of numbers? Irrationals. Good. So e is an irrational number, meaning that we can't write it as what? A fraction. Okay, so that we can't write it as a fraction. It has an approximate value of, anybody know? No, we'll give guess. It's 2.71828 ... Okay, so no, but I mean, if you knew it was about a little less than 3 or whatever, that's kind of what you need to know. Do you have to memorize the decimal? No, you do not. But you need to, as far as graphing purposes, you need to know it's about 2.7. Also for estimating purposes, just like with pi. If I was calculating something with pi and I estimated pi to be 3, that's a pretty rough estimation, but I could estimate it as 3, get a basic idea what my answer would be, and just know I'm a little on the low end, right? I can do the same thing with e. Estimate it using 3 and just know I'm a little on the high end, and I at least know if my answer is reasonable. Like, am I in the ballpark? Like, what am I looking at here? So you do need to know about 2.7.
At this time, will you please release band members and sidekicks that are participating in the tech rally?
All right. So yeah, make sure that y'all go back and watch the rest of this video because that is going to be important. All right. So exponential functions with base e are also called natural base exponential functions. We'll watch a short little video at some point next week that tells us a little bit more about e. Many real-world applications of exponential functions use base e. No, we have to, well, for graphing purposes right now, yes, 2.7 is kind of what you're going to be using in your head. We're not, oh yeah, don't forget your phone. We're not going to use all of those decimal places every time. We're going to use the calculator for that stuff anyway. But I know I said the word calculator. You're going to get them next week. It's going to be so exciting. Bye. Finally. But when we do use them, and we always round to 3 decimal places. 3 decimal places. That's an important calculus thing. So because we need to know the reciprocals of these also, we need to know the reciprocal of what this would be. Listen. So e, like e to the first power, is about 2.718. That's what we just did, right? So we also need to know what e to the negative 1 power is so we can do the graphing. And again, I'm going to give you a bunch of decimals. You don't have to know them all. We're going to write them down, but then we're just going to talk about what we know. This 0.367879, blah, blah, blah. So for purposes of graphing, you just need to know that e is about 2.7 and the reciprocal is about 0.36. That's good. These grids are small anyway. It's not like you can estimate when you're graphing, you can't make it that much more accurate anyway, so it's all good. So when we're going to graph this, we're going to graph this just like we graph the rest of them. This is an exponential growth problem, and my asymptote is going to be a y equals 0 for the parent function. Right? 0, 1, well, guess what? E to the 0 power is still 1, so 0, 1 is still my y-intercept. So I can go ahead, my asymptote is y equals 0, y-intercept is 0, 1. That's still the same. Then when I go to estimate my graphing, well, when x is 1, y is e. Well, e is about 2.7, so go to 1, 2, 2.7. See, I don't need to know all the decimals because I can't get any more accurate than that anyway. And then when x is negative 1, y is 1 over e, which is about 0.36, which is about right there. That's the best we can do when we're graphing anyway. And then it's going to look something like this. Well, actually, it's not going to be 1 over e. You'll have a negative exponent. That's a very good question. Okay, so e to the negative whatever. Yes, and that's a good question. Because what that does is then that like if this was a negative, since it's the negative on the x, that's a reflection in y, right? So then this flips around and that becomes decay. That's a very good question. So this one right here happens to be growth, right? My domain is still negative infinity to infinity, right? It's the same. My range, 0 to infinity. Not including 0 because there's an asymptote there. It's increasing the entire time, which means it's not decreasing. And then as x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x approaches 0. We're all okay with that? Those are our parent functions. That's, I think, the end of page 1, right? So now let's go talk transformations on page 2, the B part. I know. And so this was 66, right? So this one goes on page 67, okay? Ooh, dang, I know, made me angry. So this right here is just a repeat of some, well, I don't know that it looks exactly the same, but it looks very similar to what I had you put in your ISNs when we first did transformations. Tells you about the different shifts and the reflections. All that stuff is exactly the same. Same stuff on every single one of them. All right, so we just got to make sure that we can understand what's going on with this. The additional part of this that we didn't have to do with the other ones is we have to identify the parent function. I didn't always make you do, well, I guess I did make you do that. We know it's exponential, but I want more than that. So the A part, yes, it's an exponential, but you have to identify the base correctly. So this is f of x is equal, the base is 2, so 2 to the x power, that is your parent function. You need to make sure that you make note of that so you're not trying to do something with that 2. That 2 is not part of your transformations at all. Okay, does that make sense? So then the B part, we actually identify the transformations. All right, well this is 2, and then the power it's x plus 1, and then we do a minus 3. What do we always have to make sure comes last when we list them out? What did you have to do? Translations, right? You had to do all the reflections and the stretches and compressions first, right? Translations were always last. Do I have anything other than translations in this one? No. That's all I have anyway, so I can start with that. I'm going to translate, and then this x plus 1 means I go where? Left. Good. I go left 1, and the 3 means I go down 3. Okay? Everybody good with that? Same process as when we did parent function stuff before. Okay? So let's look at 2. The A part, f of x is equal to, well, the base of the exponent is 1/2 to the power of x. Good. So that 1/2 is not a stretch or a compression of any kind. That is the base of that. I ignore that and look at what everything else is happening here. So to do my translations, or my transformations rather, this negative is going to reflect it in what? Y. Or is it x? Careful. Remember, if it's directly affecting the x, it's a reflection in y. If it's directly affecting y, it's a reflection in x. It's really easy to tell with these, because it was very confused. That was something that everybody got confused on every time. If it directly affects x, it's up in the numerator, which means that is a reflection in y. When it's not in the I said numerator, up in the exponent. When it's in the exponent, it is affecting x, so it's a reflection in y. If it's not in the exponent, it's affecting the y value, so that is actually a reflection in x. Okay, so reflect in the x-axis. Way easier to tell. When it's not in the exponent, it's a reflection in the x. Then after that, all I have left are my translations, right? So I'm going to translate. That 5 is going to do what? Right 5. And that 1 is going to go up 1. Everybody good with that? Yes? All right. Let's talk through the rest of these. Make sure we got this down. So A here, my parent function, what's the parent function going to be? What's the base of the exponential? 4. What's the thing with the exponent on it? That's what you're looking for. Here's my exponent. The base of the exponent is 4. So this is 4 to the x power. Anything else that's in there is part of a transformation. So the B part, we're going to start with this negative. That means I'm going to reflect in what? X-axis. Good. So I'm going to reflect in the x-axis. And then that 3, is that going to be a vertical or a horizontal something? How do I tell? How do you know? What it affects. So does it affect the x? No, remember that's really easy to tell here. Like, is it in the exponent? If it's in the exponent, it affects x. Not in the exponent, so it doesn't affect x, which means this is affecting my y value after I do the x thing. So since it affects my y, that means it's a vertical stretch. Good, and it's a vertical stretch. This is a vertical stretch factor 3. So I reflect, I got that 3 taken care of, and then I've got translations, right? So I'm going to translate, what does the 2 do? Right 2 and down 7. Everybody good with that? All right, so this one's got an E in it. Does that mean it's going to be like crazy hard? No, it does not. So my parent function should be a lot easier to tell on this one, right? F of x is equal to e to the, well, it's just e to the x power, the positive x, that is my parent function, okay? It's always just whatever to the x, and then that negative is going to be one of my transformations, okay? So then my b part, that 4/3, does that affect x or y? Y, right? So that means it's going to be a vertical, is that going to be a stretch or compression? Stretch, because it's bigger than 1. Yeah, just because it's a fraction doesn't mean it's a compression. So this is a vertical stretch factor of 4/3, because it is bigger than 1. Then that negative on the x means I'm going to have a reflection where? Good, in the y-axis. And so I've taken care of the 4/3, I've taken care of the negative, and then I'm going to translate where? Up 5. Okay. We good with that? All right, y'all try 5 on your own. Try and get it all knocked out on your own. Let's see what happens. So what's my parent function? 2 to the x power, right? All right, so this 5, what's that going to be? Good. Vertical stretch, compression. No, factor 5 is what I'm trying to say. Factor 5. then this negative means I'm going to have what? A reflection in what? And good, in the y-axis. And then I'm going to translate right 4 and down 9. We okay with that? All right. Let's look at 6. We're not going to do all of them, but I do want to do either 6 or 8. It doesn't matter. We'll do 6. So my parent function, f of x, equals what? 2/3. Good. 2/3 to the x power. That is the base of that exponential, so that means that has nothing to do with my transformations. So then the b part, that negative is going to be a reflection in what? Good, in the x-axis. And then that 2/3 is the base, it does nothing. That 4, what is that? Good, what kind? Horizontal, good. It is a horizontal compression by a factor of what? 1/4, good, because the x lies. Everybody okay with that? All right, we want to do 7, we won't do 8, because I know it gets a little tedious, but I want to make sure we got this down. My parent function for a is e to the x power. So that negative is going to be a reflection in y. That 1/2 is good. What kind? Horizontal, good. It is a horizontal stretch, factor of 2, and then I translate up 4. Okay. Everybody good with all that? Any questions at all? All right, let's graph. Grab the next one. Oh, not the next one. Is the back? Is it number 9? I think my papers are all weird here. Okay. Okay. That's the back, and then you just have a front of the next piece of paper, right? Okay, got it. All right. Mine are just copied differently. Okay, so this graphing, we got this down. We can do this. This is not going to be that hard because parent function graphing, some of it was just, I think, hopefully we got it down at the end. Some of it was a hot mess. So the first thing we have to do is we have to identify our parent function. That is f of x equals what? 3 to the x power, right? Then we have to put our transformations down here. All that's happening here is that we're going to translate where? Right 1 and down 4. Okay, so when I go over here to do this, the first thing I want to graph is my horizontal asymptote. What is the only transformation that's going to affect my horizontal asymptote? What do you think? Down 4. It's only going to be the vertical translations. Whether I compress, stretch, either way, shrink, reflect, like none of that matters. Since it is at y equals 0, the vertical translations are the only things that affect it. So if it's at y equals 0 and the whole thing shifts down 4, then guess what? So does my asymptote. 1, 2, 3, 4. And you want that to be the first thing that you graph because it can also help you maybe catch something weird that you do because we know we're not going to cross it. So my asymptote is now at y equals -4, and I can go ahead and put that in there. You with me? All right, so then I do my translations, or my transformations rather, which is just translations here. And so I start with my anchor points. I put my pencil there, but I'm not actually making dots there. So I know I start at 0, 1 on all of them. Then from that point, I'm going to go to the right 1 and down 1, 2, 3, 4. That's my new point there. Your anchor, the other 2 anchor points are based on whatever your parent function is. That's why you want to write it out. So for my parent function, when x is 1, y is at what? 3. So I'm starting here. Then from this point, I go to the right 1 and down 1, 2, 3, 4. There's my new point. Then I go to -1. Well, when x is -1 for my parent function, I'm at 1/3. Then from there, I'm going to go to the right one and down 1, 2, 3, 4. There's my new point. I've got 3 points graphed. That should happen every single time. And then it looks like this. So my domain, what's my domain going to be every single time? Negative infinity to infinity. My range is affected by a couple of things, the vertical translations, but also some of the reflections. So, but I know my y's start at -4 and go to infinity. I never include that because there's going to be an asymptote there. My y-intercept, if that's not something that I have graphed, it's something that I have to go figure out. Now, I have it graphed, but we can think about what's happening with that as well. If I don't know what it is, I can substitute in 0 for x. So I can say I want f of 0. That's equal to 3 to, well, 0 minus 1 is -1, and then minus 4, right? So what's 3 to the -1 power? 1/3. So 1/3 minus 4. So I'm almost at 4. I'm a third shy. This is going to be what, 12/3? Would you agree with that? If I change it instead of 4, it's 12/3. So what's 1/3 minus 12/3? -11/3. So I'm at 0, -11/3. Am I increasing anywhere? Everywhere, right? So negative infinity to infinity, and then none here. It'll always be one or the other on that. And then my end behavior, as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches what? -4. Okay, everybody good with that? Any questions at all? All right, I think we can skip number 10 so I don't graph you to death. We need to do the rest of them though. And this, you need this practice because this was something that y'all, you felt like you got, and then we would go and graph things with parent functions, and then we didn't always get it, so it'll go pretty quickly. We'll be good, but we'll skip number 10. All right, let's look at number 11. So first thing I need to do is identify my parent function. That's going to be f of x equals what? 1/4, good, to the x power. And when you have a fraction, you need to put it in parentheses. Otherwise, the exponent's just going to look like it goes with the numerator, and that's not okay. So then I have my transformations. So this 3 is going to be a vertical what? Stretch. And what's the factor? Good, factor 3. And then that 5, we're going to, good, left. So we're going to translate left 5. Okay, everybody okay with that? Then let's go over here and graph. Did I have any vertical translations? Did I move up and down at all? No. That means my asymptote is still here at y equals 0. So I can go ahead and put that in. That my asymptote is at y equals 0. Then I've got to go through my process here. I start at 0, 1. I'm going to have a vertical stretch by a factor of 3. So my y value now becomes what? 3. Make sure you don't count up 3 from there because that's a common mistake. And then I translate left 5. 1, 2, 3, 4, 5. There's my new point. So then I go to when x is 1 for my parent function. When x is 1, y is 1/4, right? I have a vertical stretch by a factor of 3. So 1/4 times 3 is what? Oh, come on. 1/4 times 3. 3/4, yes. You got one of them, now you got 3 of them. So 3/4, which doesn't move me that far, right? That's my vertical stretch factor of 3. Then I translate to left 5. 1, 2, 3, 4, 5. And I'm right about there. Then I have my third anchor point. When x is -1 for my parent function, my y value would be what? 4. So 1, 2, 3, 4. So then I have a vertical stretch by a factor of 3. So my new y value would be what? 12. The graph only goes to 10, but it's okay. We can go off by 2 and figure that out. So we're up here at 12. And then I move to the left 5, 1, 2, 3, 4, 5, and it's right about there. So this got stretched, so we kind of expected that, and it's going to look something like this. Oh, but guess what we forgot? Our y-intercept, which needs to be plotted. And that's not something you get to guess off your graph. Like, could you guess right now? Because I don't think so, right? Well, you could guess, but you're not going to be right. You can plug in 0, exactly. So f of 0 is equal to 3 times 1/4 to the 0 plus 5, or to the
Good
fifth
afternoon.
power.
Pardon this interruption, teachers. At this time, please release freshmen only who have an orange pep rally ticket to go down to the gym. Thank you.
Okay, so this means 1/4 times 1/4 times 1/4 5 times. So basically, I need to know what 4 to the 5th is. Okay, so let's think about this. And we're going to think smarter, not harder, because yes, eventually you're getting calculators, but you still won't get them every single time you ever do anything. So let's think about this. I have to figure out what 4 to the 5th power is, right? Isn't that the same as 4 squared times 4 squared times 4? Would you agree with that? Like if I split it up, it's the same thing. So what's 4 squared? 16. So this is 16 times 4. Okay? What's 16 squared? Something you should know, by the way. I'm just saying. So you're close. It's 256. You should know that. So 16 squared is 256. So we get 256 times 4, right? Multiplying anything by 4 is easy because you can double it and double it again. So what's 2 times 256? That would give me, that 250 would give me 500 and then 12 more, right? So it's like 512 times 2. And then what's 512 times 2? 1,024. Now, I'm not saying write all this out all the time, but do you see the thought process? I wanted you to see the thought process. That's different than 4 times 4 is 16 times 4, and then keep going, depending on what it is. Learn how to split it up, and even if you had to do some scratch work because you don't know what some of them are, it's better than always just trying to do it the same way every single time. So just a little FYI there. So what this gives me here then is 3 times 1 over 1024. Now, is that going to be easy or difficult to figure out there? Oh. How do you multiply a whole number times a fraction? You put it over 1. That's it. So your y-intercept then is 0 and then 3 over 1,024. Okay, so it's a really tiny number, which is what we expected, right? It's on there somewhere. Bam. My domain, negative infinity to infinity. What's the range? 0 to infinity. Is it increasing anywhere? Nope. And it's decreasing where? Everywhere. And then my end behavior. As x approaches infinity, f of x approaches, as x approaches negative infinity, f of x approaches. So as x approaches infinity, f of x approaches what? 0, and this would be infinity. Okay. We good? All right, 3 more graphs, and then remember, tomorrow you're just going to get to work on this stuff. You won't have to. So we'll finish the graphs, and you won't have to watch any of the video because you will have seen it live. Okay, well, good? Sort of. Next one. All right, last piece of paper. So this is going on what, 68? Yes. All right, so now we have an E problem. F of x equals e to the negative x plus 3. So my parent function is f of x equals e to the x, right? The negative up here in the x means that I'm going to reflect in what? In the y-axis, because it's affecting x. And then I translate where? Up 3. Okay. So do any of these transformations affect my asymptote? Yes, because I go up 3, right? So instead of being at y equals 0, it's at y equals 3. So here's my asymptote. I'm going to go ahead and write y equals 3, so I'll make sure I have it done. So now I go back and I do my anchor points. I start at 0, 1 for every single one of them. I reflect in the y-axis. Well, I'm on the y-axis, so that doesn't take me anywhere. And then I translate up 3. 1, 2, 3. Then I go back for my parent function when x is 1, y is e, which is about 2.7, right? So I'm right here. I'm going to reflect in the y-axis, which ends up over here. And then I translate up 1, 2, 3, and I'm right about there. So then for my parent function, when x is -1, y is 1 over e, which is about what?
At this time, sophomores with an
0.36, yeah.
ticket may be released.
I reflect in the in the y-axis, and then go up 1, 2, 3. So it looks like this. All right. My domain goes from -infinity to infinity. What's my range? Good, 3 to infinity. Do I know exactly what my y-intercept is? Yes, there's no guessing there. So that's at 0, what? 4. I'm increasing none, decreasing the whole time. As x approaches infinity, f of x approaches 3. As x approaches -infinity, f of x approaches infinity. All right, we all good? E's not that scary, right? Don't let E be scary. All right, 2 more. We can do this. Power through. All right, number 13. So we've got my parent function being f of x equals what? Good, 1/3 to the x power. So then the transformations then, this negative is going to be a reflection in what? The x-axis. And then the 1/3, that's my base, it doesn't count. 2 is going to be what? Good. Horizontal compression, good, because x lies. Horizontal compression by a factor of 1/2, good. And then I'm going to translate where? Right 1, good. All right, so does anything affect my asymptote? 125? Oh, I thought maybe like you looked for them and they weren't there. 120, oh, end of the hallway on the left. Okay. So did it affect my asymptote at all? No. So there was no no vertical translation. All right, so I'm here. I started 0, 1. Right? I reflect in the x-axis. This time I actually can do that, right? It ends up down here. Horizontal compression, that means I multiply my x value by 1/2. Well, it's 0, so that does nothing. And then I translate to the right 1, and I end up right here. Okay. So then I'm going to go to, when I'm at 1, for my parent function, what's my y value? 1/3 when I'm at 1. So I'm at 1/3, I'm right here. So I reflect in the x-axis, I end up right there. I have a horizontal compression of 1/2. So instead of my x value being 1, I'm now at 1/2, so I'm like right there. And then I translate to the right 1, which ends up right there. And there's my point. It's kind of weird because we were at 1/3 and then 1/2, and it's just in a weird spot. Okay, so for my parent function, when x is -1, y is at 3, right? So I'm here at -1, 3. I reflect in the x-axis, so I'm down here. Horizontal compression by a factor of 1/2. So instead of x being -1, it's now -1/2. And then I move to the right 1, and I'm right there. Okay? Everybody okay with that? Those points are all kind of in a weird spot. So then my graph looks something like this. I sort of missed that point. We'll just make it bigger. Be okay. My domain is still -infinity to infinity.
At this time, any juniors with an orange pep rally ticket may be released to the pep rally.
Are any of y'all going?
Members of the cross-country team may be released to go to the pep rally.
Were you really supposed to go? If you're supposed to go, I'll let you go. They probably just forgot to call y'all. I want you to go. So you don't have to do this tonight because you're going to have time in class to work on it tomorrow. Yeah, we can finish in class. Have something to do in class. All right, so then what is my range? Where does it start? Negative infinity. Good. Negative infinity to 0, and I don't include either one of them. Don't put 0 to negative infinity because that makes no sense. You always start with the least. Y-intercept, do you know exactly what that is? No, we don't. So we've got to go figure that out, right? So I'm going to get, it's going to give me f of 0 equals negative, and then that 1/3 to the -2 power, right? Because it's going to be 2 times -1, so it's -2 power. So what is that negative, what does the negative do to this 1/3? Just the negative exponent. It flips it, right? So it's going to give me 3 squared. So what's 3 squared? It's not a hard question. What's 3 squared? 9. So it gives me -9. So 0, -9 is something I really should have graphed, and I didn't. 1, 2, 3, 4, 6, 7, 8, 9. Ooh, which means my little graph there, I got a little carried away with that. Let me fix that. So I'm going to come back and get 0, -9. I'm right here. So my graph should look more like that. I really should have calculated that before I drew in my graph because you need your y-intercept graph. That was bad on my part. Sorry about that. All right, and then the asymptote, I know, is y equals 0. Is it increasing anywhere? Everywhere, right? Negative infinity to infinity. And it's decreasing none. Then my end behavior as x approaches infinity, f of x approaches 0. And as x approaches negative infinity, f of x approaches negative infinity. Good. We're good with that? I know this is exhausting. This is longer than I really wanted it to be, but I thought it'd be better for me just to get it all done today, and then you won't have to watch another video, only if they weren't here. All right, one more. We got this. What is your parent function here? Good. It's e to the power of x. Then my parent function, not my parent function, that's what we just did. My transformations, so there's nothing in front of the e there. This 1/3 is going to be a what? Good. Horizontal stretch. Good.
At this time, any seniors with an orange pep rally ticket may be released, and members of the varsity basketball team.
They forgot them. All right, so then that's it for that stuff. So then I'm going to translate left 2 and down 1. All right. So does my asymptote get affected here? Yes. We went down 1, so it's now at -1. So I'm here. So this y equals -1. Then I'm going to go plot my points. So I'm at 0, 1 to start with. Horizontal stretch by a factor of 3. That means I multiply the x value by 3. X is 0, so I go nowhere. Then I translate to the left 2 and down 1. I'm right here. For my parent function, when x is 1, y is e, which is about 2.7. So you go up to about 2.7. I have a horizontal stretch by a factor of 3. So my x value is 1. My new x value now is 3, right? So I go to the x value of 3. I'm still at 2.7 for y. Then I translate to the left 2 and down 1, and I end up right about there. Then for my parent function, when I'm at -1, I'm at about 0.36 something. Horizontal stretch by a factor of 3, which means my new x value is -3. Then I go to the left 2 and down 1, and I'm right about there. But I'm missing my y-intercept, so let's go find that before we graph this time. So my y-intercept, that means I need f of 0. So it's going to be e to the 1/3 times, and the exponent, 1/3 times 0 plus 2, which is going to be times 2 minus 1. Well, what's 1/3 times 2? 2/3. So this is e to the 2/3 power minus 1. Do you have any idea what that is? Yeah, me either. And that's okay. I don't expect you to know, okay? It's kind of like if we would have gotten a weird square root here. You don't necessarily know what it is. That's okay. So this is an exact answer that we don't really like, but it's an exact answer. I'm going to go ahead and put that over here for my y-intercept. I'm at 0, comma, e to the 2/3 power minus 1. That's the best I can do right now. So I'm not plotting anything because I don't even know where the heck to put that. So then I go ahead and draw in my graph. Now when I do that, now looking at your graph, could you tell me e to the 2/3 minus 1 would be about what? About 1. Yeah, because you see here where it crosses? It's actually as a decimal like 0.95, which is really close to 1. So estimating on my graph about 1, if that's good, right? So I feel good about my graph. So then the domain is going to be the same as negative infinity to infinity, like it has been. Whew, that's a weird looking infinity, but it works. Then we're going from, for my range, -1 to infinity. And we're increasing everywhere. And we're decreasing none. Then we got our end behavior. So as x approaches infinity, what does f of x approach? Infinity, good. And then as x approaches negative infinity, f of x approaches -1. Okay. So how we feel about graphing? Feel like you can do this? Does it make sense? I feel like you have a question, Hector. I feel like you have a question. Are you sure? Back over here, did I lose you somewhere? It just felt like by the way you were looking at it. I'm just making sure. Okay. All right, we're all good? Go ahead and glue these or tape these in now so that you don't have to worry about it later.